Hello everyone, I'm Pedro, a Rocketeer, a student of a school previously founded by Elon Musk, and today I interviewed the Red Rocket Experiment Division that will compete for the 3 kilometer solid competition at EuRoC 2022. So could you please introduce yourself and how many you are in your team?
My name is Pedro Rosado. I'm the coordinator of Red, and this is Carmen. So,
hello, I'm Carmen Fonseca, and I'm the technical director for the Red team.
Yes, so Red is short for Rocket Experiment Division. We are a student rocket team from Instituto Superior Técnico, which is part of the University of Lisbon, and we were founded in 2017. Red is also part of a bigger student association, which is called AeroTéc. AeroTéc is the student association for aerospace engineering students from Técnico. And AeroTéc has also a different number of projects, and Red is one of them. So we are the pioneer student rocket team in Portugal. So we were the first ones, even though now there are more and more teams in Portugal that are also developing rockets. And this year there is also another Portuguese team in EuRoC. Right now we are approximately 70 members in our project, and we are divided in 6 different teams. So we have 5 technical teams, which are control, electronics, structures and aerodynamics, propulsion and recovery. And then we have our management and marketing department, which is responsible for promoting the work that we do in our projects. So right now, each project has their own team leader. Each team has their own team leader, and then we have some teams that have some sub-team leaders, which have some minor responsibilities and help in the organization of the team. I would also like to say that we try to emphasize the importance of having members that have different technical backgrounds. And even though we are part of a student association that is from aerospace engineering, we have different members that have different backgrounds and that come from different courses. We have people that are from chemical engineering, from mechanical engineering, from materials, from electronics. So it's important that in any scientific field, and more so in aerospace engineering, that we have people that have different knowledges so that we can all work together and develop, in this case, these rockets. Our mission, besides developing our rocket for the competition, is also to try to contribute the more we can. Is also to try to contribute to the Portuguese space ecosystem and try to create awareness about this industry. And even though it's still very small industry in Portugal, we are trying to develop it in our own little way. And so we try to both talk to students in high schools and also try to develop our relationship with private companies and already working professionals.
How did you start your team?
Our team actually started with an idea from 2 students. So in 2017, these 2 aerospace students were very interested in the other foreign teams that were being created. And they really wanted to create a Portuguese team that could also compete with them and that could also build rockets. And so they started with a small group of people, and then they grew each year through the recruitment seasons. They could also have more and more candidates and more recruits that wanted to help and produce these rockets. And now we are a big team of 70 people. So we first started with our first mission, which was the pilot mission, which was a rocket that wasn't bigger than probably this much. Now we have a 3-meter rocket, so we have had an exponential growth through these years. We are now also trying to have a better relationship with the industry and companies that want to work with us. So in the beginning, it was really difficult to find funding because we didn't have experience, we didn't have a lot of results to show to the industry and to possible sponsors. And so now, the more we do and the more projects that we develop inside our team, it's easier and easier to find and to find new partners and to make them interested in the work that we do here.
How is it to study in Portugal, and can you study in English?
In Portugal, you can study in English, but it's all the master courses are in English, although the bachelor courses usually are in Portuguese, unless you ask the professor to speak in English. I think we are trying to change it. I think we are trying to be full on English so that we can accept more Erasmus students and mobility students. Studying in Portugal the courses are very theoretical still, which is why projects like RAD are very important. So that you can apply the things that you learn in classes to a real life project. Our university in particular is trying to change that. We're trying to give more and more importance to laboratory activities and to projects on each course. The university life is very pleasant. I always, when we have mobility students, they always talk nice things about that. We have lots of barbecues, so to say, in Technical, and many parties inside and outside the campus. And also day to day, you have lots of coffee places to hang out and to chill out a bit when you're having a break from classes or from studying. There isn't any accommodation inside the campus. Most people rent apartments. And we have two campuses in Technical, which is Tagus Park and Alameda. And they're kind of distance from each other, and they have different courses from one another. But yeah, on our campus, as to talking about maybe more of the space activity on our campus and university, we didn't have any space-related projects up until RAD was founded, which is why we were founded to kickstart that process. But yes, we have lots of Erasmus students, especially in the master's degree, as I said, because they are in English. The tuition fees are a bit different. It depends if you're a national citizen. It depends if you're a full-on foreign student or if you are an Erasmus student. Our university is very welcoming of foreign students.
What are the job opportunities after your university?
We actually have some different job shops, which are some weekly events where different courses from our university organize this week, where different professionals and different companies come to our university and to our campus, and they can give us some lectures. They can we can talk to them directly and understand what they do in their day-to-day life and what their work consists on. And during these weeks, we have opportunities to for example, organize some summer internships and other events that we can then use in our advantages to understand what we can do in the future. Right now, we, for example, have an aerospace week which is also a project from AeroTéc, where students are able to organize this event where different people and professionals from around the world can participate and teach us what they do and tell us what their work consists on. And actually, one of RAD's main goals as well is to improve our connection and the connection that the students and our members have with the industry. And we feel that it will be a great opportunity not just to enlarge our network, but also to get closer to the professional fields. And we have, for example, many of our members and collaborators who right now are doing some internships with companies that are our sponsors and partners. And so even though most of us don't know what they want to do exactly in their future, most of us want to work in this industry and in this area, and to be already in contact with these companies, it's a great opportunity for us to learn more about what we want to do in our future. And even though the Portuguese space industry is still very small and still in their early developments, we really want to prepare our members and ourselves to new opportunities, national and European-wide.
What are your team's goals?
So I think our team's goals can be divided into multiple categories. On the short term, we obviously have this year's EuRoC 22, and we have the next year's, which we are already preparing for, which is EuRoC 2023. And we obviously want to excel in our category and to be always better and increase our performance in it. Midterm, I'd say, as Pedro already mentioned, we want to keep networking and improving our relationship with different space identities in Portugal, Portugal Space and other companies that are more and more developing space technology. And also to network with different universities and also high school students, which I will mention, to develop for us interesting scientific experiments, different payloads for us to launch. It would be very interesting for us. For instance, Baltasar, which is our 2022 rocket, we are going to launch a payload that is from a national CanSat competition. So for us to be a part of those initiatives is very important. On the long term, I'd say we are developing a hybrid propulsion rocket. And we are also doing some research on thrust vector control, but that is very, very long term, because that's a thing that takes a while to develop. Our project in that area is very inspired in BPS.space, which I think you might know on YouTube. We have interest in that because we believe that reusable rockets are the future, and there should be more people working on them. Our goal is always to keep going to high schools, keep going to every event, so that we can inspire the youth to follow a career in aerospace and in space and rocketry, and go to either aerospace engineering or another engineering where you can contribute to this amazing industry. So I believe that's our main mission in Portugal, I'd say.
How can members join your team?
Before students actually come to university and they can officially be able to be part of our team, we sometimes go to different high schools where we have the opportunity to present our project to younger students and to show them what our work consists on. And we have also an opportunity to do some little workshop with them where they have an opportunity to have a hands-on experience on what rocketry is. And for example, we do some little rockets from wood and from paper. And they have also an opportunity to launch them. They don't go higher than probably 100 meters, but it's a good opportunity for them to have their first experience with rockets. And there we can talk to them about which courses Technic has and what aerospace engineering is. And so when they come to Technic, if they come, then they already have a basic idea of what we do. Recruitment-wise, this year and on our last recruitment season, which was in March this year, we always have 2 recruitment seasons, one in the first semester and a second one in the second semester. And this year, our latest recruitment season was the one that was just after EuRoC. And we really felt that the visibility of the competition really made the students even more interested in our project. And we actually had probably around 100 applications, and we usually have like 30, 40 applications, no more than that. And so we felt that the competition really gave us more visibility near the student community. And in our recruitments, we really do value more your hard work and your curiosity more than your actual knowledge. So even though we really value when recruits and new members already have some specific knowledge and they already know how to do things, we really try to emphasize that we are all here to learn. And even though we that are already part of the team already have some basic knowledge and we already know things that probably new recruits don't, we are all here to learn together. And we are not here just to teach anyone how to do things for themselves. This is a very dynamic relationship. And so we really try to emphasize that you don't need to know a lot to come here. You just need to be able to work with us and to be curious enough to want to develop your knowledge. Unfortunately, because we are part of Technic, we only can accept students from Technic to be officially part of our team. However, we have the opportunity to work alongside and to collaborate with different students from other universities. For example, we have our payload this year. One of our payloads actually, both of our payloads are not developed by us, and so we have an opportunity to collaborate with both. With one of them with high school students, and with another with the other, we have the opportunity to collaborate with different students from both Technic, but also different universities. But they cannot actually be part of our team because of legal reasons and insurance and other bureaucratic reasons that they cannot apply to. I think that is you asked us if we made like any funny question during our interviews process. And I think that one question that we do a lot is if the new recruits are willing to work during summertime, because lots of work that we do, and because of the timing of our competition during summertime is always a time where we are always working in our laboratory. So it's really important to know if newcomers are willing to work during that sunny time.
When new members come to our team, we always try to give them recruitment projects that are both challenging for them and interesting for them to motivate them, but also useful for us. So we try to make them work on themes or systems that are going to be actually implemented in our rockets. We always make an effort to do so. And I believe that makes them feel useful, and that makes them more motivated to make the effort to develop that. When we can't do that, we usually give members more of an investigation project where they can investigate new systems that we ourselves, since we are developing the rocket, we cannot have time to research different alternatives, and that is always important, to research different alternatives and do trade-off studies. And so for the recruitment is basically that. Each team has with the different team leader of each team, they delegate the recruits each project for each one, and then at the end of the recruitment process, they have an evaluation, and the team leaders give them some feedback.
What can members learn in your team?
The skills that you can learn are basically, I'd say, unlimited. It depends on your will to learn and to work. We always try to encourage the recruits to not only to learn what we know, but also to go beyond that and to contribute to our pool of knowledge, because we always believe that we can do better than what we are already doing. So that is very important, a very important attitude to have, a humble attitude, that we can always grow even more. So when a new recruit comes, they know that, okay, you already can do this and that, and I'm going to learn that, but also I'm going to give my own contribution and give my own sort of perspective on a certain topic. The time that you participate in a project always depends on the timing where for example, on your course where you enter. If you enter on a later stage of your course, obviously you're not going to stay more than 1 year perhaps, but usually our members stay for 1-2 years. I think our record is 3 years and a half. And yeah, on RAD you can learn lots of things. For instance, you can learn about composite laminating, which we do a lot ourselves. Finite element analysis to calculate the structural margins on the components. CFD analysis, 3D printing, CNC machining. Also on the propulsion team we have propellant manufacturing and everything that involves our motor, because we develop it ourselves. Lots of programming on the control team and electronics team, and soldering of the printed circuit boards. And on the recovery team, we have lots of sewing also, because we develop our own drogue parachutes. And obviously on the management and marketing department, we have lots of things like graphic design, video editing, and that's always nice skills to have, even if you're in the engineering world. But yes, we always try to make the members on our teams as multidisciplinary as possible, because we believe that if you have a member that can understand the language, even though he is in propulsion, he can understand the language of the electronics team. It's very, very important to have communication and to have a full functioning project, so that we can all improve the amount of teamwork and how you deal with other people, how do you communicate your ideas.
How do you manage and support your team?
We use one tool that is very important for us to organize our workspace and to organize all the events and tests that we need to do until the competition. So we now use ClickUp, which is one of our sponsors. We use ClickUp rather than Trello, because we feel like ClickUp is more complete and we can use it better than Trello. So we always try to delegate different tasks to different people and to give them deadlines, because we really do feel that when you give a date for someone to have their work done, to have everything prepared, is easier for them to organize themselves in their time span. And so we really try to do that this year, to have to give people certain tasks and certain deadlines for them to complete those tasks. This year we weren't really successful in using new system engineering tools, so we had to use Excel and spreadsheets. But that's something that we are really trying to improve, because now we are developing more and more complex projects. And so the more complex the project gets, the more components and parts it gets. And so it's really difficult to stay on track on everything that we are doing. And so we really feel that we need to improve in that area. But this year was already a huge improvement in comparison to last year. So actually, we have worked with ValidSpace, which is one system engineering tool. But we are always trying to improve, and we feel that we can do even more. And this year we didn't use ValidSpace very much, because we have always members coming in and coming out, and we feel like it's a bit difficult to always be explaining to new members how to use this software, that it's not that easy to navigate through. And so we are really trying to explore new ways of organizing the different data that we have for the different technical teams. So right now, we usually have weekly meetings that are mostly online. So we have meetings where each team, where each team leader actually reviews the work that each team member develops inside their respective team. And then we have meetings with all team leaders, where we can talk about major developments, and where we can talk about when we are going to launch and other important issues. So right now we also have our biggest communication channel is Slack, where we have all channels open for everyone to know what's happening in every team. And I think that is what Carmen said before, that we always try to explain to the different members that they are supposed to understand, even in a basic level, what is happening in the other teams. So for example, if you're part of the propulsion team, but you really want to understand more of what's happening on the electronics team, you really can go through their documents and understand what they're doing, and ask them questions and learn with them, and really try to promote that. Besides our team leaders and our team members, we also have our board, which is composed by the project coordinator, which is me, and then the technical director, which is Carmen, and also our vice director positions. And we are, of course, responsible for not just the system engineering, but for organizing the team and for major logistic problems. And so we are always talking to the different team leaders and to the different team members to understand what we can do better, and what do they need. And of course, finding funding, which is something that is very important in a project like RED, where everything is always so expensive. And so we always need to guarantee that we have funding to do our activities.
How's the experimental rocketry community in your country?
The space industry in Portugal is yet in its early stages, so it's not yet very developed. But last year we were the only Portuguese team at EuRoC, but this year there's another Portuguese team, which we are very happy about, which is Fenix. And in the future, we really would like to collaborate more with them and to share with them our knowledge and our expertise, because of course we have been doing this for a longer period of time. And we would really like to work alongside them to make this space industry grow in Portugal. And we really do feel that there is a bigger interest from students and from professionals inside and outside this area, and they really are interested in making part of this space industry. And we do feel that people now more than ever understand the importance of this industry, and they are willing to take part on this. And even though at RED we were the pioneers and the first ones to develop this student rocket team, we are really excited to see new teams developing in our country, and we really want to collaborate with all of them, because we are all here for the same purpose. And so if we can help each other and make a brighter future for aerospace engineering and for the space industry, we are all up for it. We are also in contact with some foreign teams and some international teams, and we are always up to date with what they are doing and checking on what their new advances were. And it's also great to be in contact with the other teams, even though we are competing in the same competition. It's always great to change ideas and feedback and share knowledge, and that's actually one of the values of EuRoC. And so we really try to promote this idea of dynamic flow of knowledge.
How can you support and promote the Open Launch Initiative?
We would be very happy to help, and 100% through the communication with other teams or sharing the knowledge, or it's very important for us to help on that. In Portugal, we have not very strict laws as other countries have. We usually launch in military shooting ranges or military bases. We have lots of support from the army and the armed forces of our country, which is something that we know that other teams do not have access to. I think that's giving access to that for other teams would be very interesting, so that we can help them test our rockets before the competition and make the rockets fly, even though they cannot fly in their country. I think we could help on that. This year has been challenging, particularly because of the unfortunate situation with the wildfires during summer. So we couldn't launch our rocket for a very long time because of that. But in any other time of the year, I think we could make that process more easy on both ourselves and other teams. And I think that would be our contribution. Yes. So I actually have a funny story on the launch. So last year on EuRoC, we had as you know, on EuRoC, you have launch windows and you have to respect them. Otherwise, you cannot launch our rocket anymore on that day. So in our launch day, we had a date schedule which was for the afternoon at 5 p.m. Some of our team members had to go to the launch site and to prepare the motor and to prepare everything that is for the propellant. And our past team coordinator pranked the members that weren't there. He pranked the members that were still on the camping site. He said that we were going to launch in about 3 hours. So that was general panic for everyone, because we still had lots of things to prepare. So when we got there, we were actually very mad at him for doing that, because we were very stressed. And so if you don't know, Santa Margarida, which is where you launch, about an hour away from the paddock of EuRoC. So we still have a long way to go there, and it was very stressful. In hindsight, it's funny. So I think that's a good story to tell.
How do you promote your team?
Now we have, as I said before, a management and marketing team, which is composed by around 13 people right now, which is a lot of people for a marketing team. And in this team and in this department, there is always work to be done. So right now we have some social media platforms. For example, we have mainly Instagram, but we have created LinkedIn more recently. Besides our own independent social platforms, we also have our student associations, AeroTéc ones, so we can also promote our work there. Besides, we have our sponsors and our partners who are so we are always looking, and even though we have our current ones, we are always looking for new companies and institutions that can help us move forward and develop our project, because it's essential that we can find funding for what we do, because finding suppliers and manufacturing our parts for our rocket is always really expensive, and so we need to make sure that we have funding for all of this. And so recently we really find that it is really difficult to find partners that can help us financially directly. So it's more usually that our sponsors can participate in our project through a logistic partnership, which means that they can help us manufacture our parts. But in certain situations, we have no other option than to have money ourselves to take part on these situations. Besides, we would also like to host and organize more events. Actually, this year we had the opportunity to host special events in SEDEMAG Foundation. SEDEMAG, if you don't know, is a Portuguese Nobel Prize winner. He was a very known Portuguese writer, and our rocket names, so Blimunda and Baltasar, are the names of two characters from one of his most known books. And so we had an opportunity to go to this foundation and to present our project. And so it was a very special opportunity for us, and we would like to do that more, because we feel that people really have an opportunity to learn about what we do and what our work is at SRAD. About our sponsors, we offer a number of advantages. For example, they have an opportunity to have their logo on our fuselage. They can be present on the launches. Their logo is also present in our merch, in our newsletter, and they are also present in various number of our social media posts. Besides, we always try to promote an easier contact between the industry and our members. And so, for example, they have access to our members' CVs. And so this can help our collaborators to have opportunities like internships at these companies. We really felt that after EuRoC last year, our visibility went through the roof, and we really had an opportunity to understand that these competitions are really important for us to share and promote our work. And so it was a great opportunity for us to be part of this competition, and we really understood the importance of it. Besides that, we are always trying to also promote our work inside our own university campus, because sometimes some teachers and some students who don't know our project and would be really interested in being part of it don't know it. And so if we can promote our project inside our campus, it's always a great opportunity for us to find new professors and new students who are really interested in being part of our team.
What are your experiences at EuRoC?
So last year's EuRoC was our first competition, as we have already said. It was an amazing experience. It was very game-changing for the whole project. I believe that having a competition really changes up the rhythm that you have inside the project and really motivates everyone to work even harder. And being in contact with the other teams, talking to them, sharing our experiences, sharing our pains and sharing our accomplishments was very good. It was very good. And to realize that we are understood in the way that we do some things, and some things that we do that don't work, it was very nice. And it was an amazing event, actually. It was an amazing week. And actually, we had, it was the best team building experience that we ever had, because we slept and ate and were on the paddock 24/7 all together on a very stressful occasion. And I think that made us leave the competition even stronger than when we entered. Blimunda had some shortcomings and some obstacles pre-development. So we actually have had a very small time to develop Blimunda, the rocket, and to produce it. So even though we, on our category, which was the same as this year's with the 3K solid, we didn't recover, and we didn't have the best performance. For us to be able to participate, to be able to launch, was already such a big win, and we were so happy. And we have some videos that show our reaction to the rocket being launched. For us, that was such a big win already that the whole experience was already worth it. And the effort that we made on those months to develop the rocket was very worth it. This year, obviously, we will participate in the same category. We are more prepared. We want to have a better performance in every kind of way. We have a better design. I can say that we could reduce 10 kilograms of dry mass on our rocket, so it's very optimized. We learned a lot from our mistakes, and we learned what went wrong, what went good with Blimunda. So this rocket is a very big evolution from the last years. Planning the rocket is not an easy task. We always have to do lots of planning on the logistics, on what we're going to eat, where we're going to stay, planning what different activities and the transportation of people and the tools and the rockets. There's a limit on the rocket to bring 30 people, and since we have the advantage to be the team of the house and we don't have to take a plane to go to the site, fortunately, we will bring 30 team members this year. We have a professor that is our mentor professor, our advisory professor. Unfortunately, he will not be able to be there with us through the whole week, but he will be there from time to time on the paddock to talk with us and to give us some feedback on our performance on the competition. So we do have a mascot. We have a mascot called Scarlatti, which is inspired on Memorial do Convento, which is the book that Pedro mentioned, that inspired our this year's and last year's mission name, Baltasar and Limunda. His story is presented in comics that are published in our newsletters. So the comics are a little bit about his story and the story of the team and the developments that we have. That's a recent thing that our marketing team did, which I think is very cool. So yes, top competitors and favorites. I believe that obviously the previous overall winner, EPFL, is a very big contender. They are very professionalized, they have a big budget, and they are a very well-organized team overall. In our category, we obviously have the Graz team, which won the technical award last year, and Skyward, which won the 3K Solids prize and also the team awards. And shout out to them because they really deserved that team award. They were tireless in helping us both in our recovery systems and both in our problems that we have with our egg timer, which is the COTS computer. So we are very, very thankful for them. And we are always talking with them to make them some questions, share with them some experiences. So yeah, they are a very cool team. But yeah, we are competing we are always competing, and we always try to do as best as we can on the competition. But obviously we want every team to succeed. It's very sad when you are at the launch site or when you are at the paddock and some team cannot launch for any reason or any technical problem that they had. Everyone gets sad. It's not just them. No one gets happy for the misery of others. So when they do launch, they do have a good competition. Everyone is clapping, everyone is happy. Because once again, we are all in there to do rocketry, and that's what we love. And we want everyone to succeed as best as they can because everyone worked very hard to be there. But yeah, so our plans for this year is basically that, to compete and be good in that same category. We want to compete in the next year also, perhaps win, let's say. We're going to work on that. We're going to work towards that. And yes, keep working, keep improving, and keep learning with other teams.
How is the technical review process at EuRoC?
So the technical review process is very strict, I'd say, and it's good that it is strict. Usually it's me, the technical director, that is responsible for this part, that is responsible for overseeing all the documents that we have to write, the deliverables that we have to write pre-competition. We have to prepare during the full year and to document everything that we are developing, so that when the time comes to deliver, for instance, the concept report or a technical report, we just have to compile it and to write it in a concise and clear way. That is very important for us, not only to deliver to the competition, but also to have that internally and to store the knowledge and guarantee that the members in the future have access to it and can understand it, the things that we've done and the knowledge that we have already acquired. This was actually something that we struggled in the past to do. So this year we made a huge effort to improve on that. These documents are very important for our scoring system in the EuRoC. This year we had the concept review, which was something that didn't happen last year. It was a new thing that the EuRoC organization implemented. You had to write basically a short version of the technical report and explain all your systems in a very concise way. And then you had the concept review, which was basically when the juries read your report and they wanted to ask you some questions. This year's was very good. We had very positive feedback. Which was very soothing for us that we were on a good path to develop the rocket. The juries didn't ask us for us to write a design report, which was an additional report that if they felt that you needed to write, they asked you for it. So us not having to do that was a good indicative that we were that the juries were confident that we were going to have a good performance. And this year, we actually last week we delivered the technical report, which was a very big improvement from last year's technical report. But yeah, I think these documents are very important for us to always be very we always want to do better, and these documents make us do that. So our decisions in the technical process have to be justified. They have to be all throughout documented, and everything has to be well organized. And I think these deliverables and the way that the competition is structured, it's a very big incentive to do so.
Would you like to join another competition like Spaceport America?
In the near future, which is about in the next 2 to 3 years, we want to keep participating in EuRoC, and we believe that we have a big responsibility being the first team on the house to compete. We have a big responsibility to keep participating, to keep giving visibility of the in-house competition and represent Portugal in our own country. But we do want to, in the long term, participate in, for instance, Spaceport America Cup. I believe that would be an amazing experience also because we would have contact with even more teams from another continent. It's a more, I'd say, mature competition because EuRoC is also very recent. And yeah, with the creation of new teams in Portugal, I believe that having a national competition will be also interesting because since we have already another 2 teams besides the Reds, I think it would be cool for us to come together and to launch our rockets together and to share knowledge and ideas. Would be very cool. It's so important to represent that there is interest in Europe, for young people to do rockets and build rockets, which was the industry of rocketry is it's much more incentivized in America, and competitions like this help to give visibility to the students who are interested in building rockets, who want to pursue a career on that. And yeah, I think that being able to host that in our country is something that we are very proud, and something that we are aware of the responsibility that brings to us as the team on the house. But yeah, I don't know any other competition besides Spaceport America and EuRoC. If you know any, you could let us know. But yeah, we are always very excited to join these opportunities, to learn and to grow even more.
How much does it cost to build your rocket?
So it's always really difficult to find funding for our project, as I said before. But we are really proud for the fact that even with less resources than other teams, we are able to produce a rocket and to compete alongside them. So this year, the cost of our rocket was between $25,000 and $30,000, €1,000. Last year we had an even smaller budget, and it's always difficult to find funding. So our partners this year were really helpful in the manufacturing process. For example, even though in Lisbon, which is where we are from, there are not a lot of companies that are able to help us during this manufacturing process. Most of the companies that are able to help us are from the north of the country. Which, if you know, from Lisbon to Porto, which is the second biggest city, is around 3 hours. So it's always a big logistic to go to these companies, and so it's not very easy for us. Besides, because we are always trying to make our rocket the most SRAD possible, from the electronics to fuel to our motor design. We also try to do the most that we can in the house. For example, our parachutes, for example, as well. So we always try to do the most that we can in house and in our university, and with companies that are near us that can be a useful resource and that are easier for us to go to. But then we have major parts of our rocket, for example, our fuselage, which is produced in a company from one of our sponsors that is, again, in the north of the country. And so we cannot be directly there, but we are always trying to accompany the process of the making of the fuselage, for example. And we are also always in contact with our partners to know how our parts are coming out and if everything is okay, if they need our help. And so we always try to keep up with the advances in the different parts of our rocket. About some famous sponsors that we might have. We have one sponsor that is really well known in Portugal. I don't know if you know, which is Amorim. Amorim is the biggest producer of cork in Portugal, and since Portugal is the biggest export of cork in the world, probably Amorim, I don't know if this is true, but probably they are the biggest company that produces cork in the world. They also help the Apollo missions with these components, so they have been working with the aerospace industry for a long time. And then we have another sponsor that is more well known, European wide at least, which is called D-Orbit. They also help others rocket teams, and they have been a great help for us this year. Really sometimes struggle to find partners that can help us with our parts because and with the manufacturing of our components, because we sometimes need really precise materials or really precise procedures that not all companies can help us with. And so it's difficult to find companies that have this kind of technology that is high cost, and not all of them have these resources that we need to have.
How much do you build your rocket, and how much do you outsource to sponsors?
We do lots of things in-house. For instance, we do our own rocket propellant, which is rocket candy, a mixture of potassium nitrate and sorbitol. We also produce our own thermliner with the cork that Pedro mentions, which is something that we developed in-house, a mixture of different materials. We do some things such as our nose cone, which is we laminate it ourselves, but we do it with the help of companies. But some things like machine parts, metallic machine parts, we have to, because we do not have the tools to do so, we have to do it through our sponsors. But lots of things like 3D printing, our own things of the rockets, soldering of the PCBs, the programming part, obviously, the gluing of some components, the drop parachute also, it's all things that we do ourselves. And we are always trying to increase how much we do it in our laboratory. We do not have a very fancy laboratory, so sometimes it's much better to do it outside of it, kind of a balance in what you do and what you do in laboratory or what you do outside through the help of sponsors. As for unique characteristics, I already mentioned the cork in the thermal liner of our rocket motor. This year, this isn't a very big unique difference in comparison with other teams, because I think other teams implemented, but we have a window in our rocket that allows for camera video to be recorded. The scientific payloads are very unique this year, and they are both outsourced, as we said. Yeah, we've had lots of big developments in our software, in our prediction of apogee software, which is full-on built by students. And yeah, as I said, we drove parachutes. And we on the future, we will want to have more SRAD components, especially in our recovery systems, both in the pyrotechnic devices and also the main parachute, for instance. We want to develop it and to sew it ourselves.
I also had a question for you. Why do you use sorbitol as the fuel of your rockets?
So we use the rocket candy because of its non-toxicity, and also because we have it's easy for us to get the reagents that we need to produce it. So in Portugal, we do not have access to many other fancy types of reagents. So sorbitol, which is a sugar basically, and then we have potassium nitrate, which we can also acquire here in our country. It's a very good choice and a very safe choice, because It's something that we've tested a lot on previous years. It was always our propellant of choice in red. And so since we know that it works, we know how to handle it. It's not toxic. It always seems like the better.
Yes, but like why sorbitol instead of just regular table sugar?
I cannot answer that myself. I think that if we had here one of our propulsion team members that could answer you that. Perhaps it has to do with the granularity of it.
I think it could be more like casting.
Yeah,
I believe
like
a powder.
The casting process.
Yes, probably.
Like, how do you put the fuel in the rocket? Do you like melt it and cast it?
So we have a casting process. We have the molds, and then we demold them, the grains. So you can hold it, and then we have multiple grains. Yeah. So and then we demold them, and then we insert them into our motor casing with our thermal liner around it, the multiple stacks of grain, and then that's how we do it. Yeah.
So I think that the sorbitol would be at this point for casting. It would be more easy to cast.
Mm-hmm. Mm-hmm. I would say so. Yeah.
Because normal sugar is sort of hard to cast, since it doesn't melt.
Yeah.
It becomes glucose and fructose, and then these melt, but they also, at the melting temperature, start to decompose.
Yeah, we bring I know that we bring the mixture higher than the boiling point of water, so we bring it to 100-something degrees. So it's very important for us that the texture is very homogeneous and uniform. So I believe that the granularity of table sugar would be something that would cause a problem in that regard.
I usually grind it.
You grind it? Okay.
And if you melt it and you mix it, then it doesn't really matter. Although if it's a fine powder, it's easier to melt. Although what I can say that with table sugar, it like starts to melt at 150. And you can't really go over that since it then starts to burn. Mm-hmm. So it's hard to cast since you have like a couple of seconds.
Yeah.
Like 15 seconds of something which is sort of like clay, but is really hot. So it's uncomfortable to touch.
Yeah, I don't think we go beyond 150 degrees Celsius. But yeah, since the sorbitol is already a fine powder when we buy it, it's easier for us to use it.
What software do you use to design the engine and the rocket?
So we use multiple softwares. For the design of the overall rocket, we use SolidWorks for the CAD design. We use FEMAP, which is a structural analysis software, a finite element analysis. For the CFD analysis, the computational fluid dynamics, we use STAR CCM, which is a software that many other teams use also. To project the motor and to design and to predict the motor's performance, we use OpenMotor. And then to bring it all together and to see the stability of the rocket and trajectory, we have OpenRocket, which is an open source software. To design the PCBs, we use KiCad to design our own printed circuit boards. And then to develop the control that controls to do the apogee control of the rocket, we program on MATLAB and Simulink, which is something that we already know from some courses that we have on our college. So we always try to keep using the same software that our university uses, so that when new members enter RAD, they already know how to manipulate those tools. So it's a much better and easier process to integrate them and to make them start working. In-house, so the flight simulation, we not only use OpenRocket, we develop, as I said, our own simulator, so we can cross-check both of them to compare them and to better predict the trajectory that our rocket is going to have. This year, we've actually implemented with Python a program that calculates the margins of safety, the structural margins of safety of fasteners. So, for example, you have a bolt on some components, and you know that bolt is going to be, very big loads are going to be applied to that bolt. You put the bolt on we have a library of different bolts, you put it there, you put the loads that are going to be applied, and then it calculates the margins of safety according to the ECSS standards. So I think that's very cool because I have a background in structures and aerodynamics, so yeah, that was a very cool thing that we developed this year. In the propulsion team, we test, usually we prototype, we test on smaller motors. About 3 years ago, we had a rocket called Aurora, which was the class was of the motor, I believe, was K class. So it's a smaller motor. So we usually try to do some tests and some innovations that we want to implement in a bigger motor on a smaller, then test it and see how it goes. We built our own test bench this year, a full-on new test bench. And then, so testing on a small motor, we then go to the actual rocket motor and do some static fires and try to detect errors possible errors or underperformances that we detect or overperformances. We have, as I said, we have some sponsors that produce some parts for us, especially the metallic ones. But we test, we usually print 3D parts so that we can test fittings and test how the components are going to be fitting with one another and how they're going to be disposed inside the rocket. As for the electrical departments, as I said, the printed circuit boards are all designed ourselves. We then ship them to us, but then the soldering is all done by our electronics team. And then it's basically test, and iterate on the circuits. And that is very important, especially in the electronics team, because electronics, there's always something wrong. Nothing goes right at the first time or the second time. So it's very important to test and iterate on the work that you've done.
How do you make your engine?
For our category is SRAD, so we produce and we develop our own motor. As Carmen said before, we first tested our fuel and our development in smaller motors from our previous mission, Aurora. And then more recently, we started to do some hot fire tests in the bigger rocket that is going to be applied at Baltasar. Besides that, we are now in, as we said before as well, we are now in the early developments of our hybrid motor that we would really like to have functional in around 2 years, so that we could then integrate it in a competition rocket. It would be really cool. We haven't yet thought about a liquid motor, because now we have the knowledge and the expertise to develop and to work with a solid motor. We are now in the early phases of developing a hybrid motor, and so only after we have the hybrid motor totally developed and we master its production and its development, then we might think about developing a liquid motor. But right now we don't have the money to do it, because building a liquid motor is also very expensive, and we don't have yet the expertise to produce it as well, because it's way more complex and it's way more complicated than anything we have done before propulsion-wise. And so first we want to build our hybrid motor and to learn from it, and then we might in the future, long-term future, we might develop a liquid motor. Besides, since the hybrid motor also has a solid part, that's why it's motor, of course, hybrid, of course, it's also an opportunity for us to apply all the expertise and all the knowledge that we gathered from the development of our solid motor. Our oxidizer right now is nitrous oxides and O2, and our fuel is paraffin, ABS, and HTPV, which is also used by NASA and throughout the industry.
What electronic sensors and PCBs do you use?
On board of our rocket, we have multiple sensors. We have a gyroscope, an altimeter, accelerometer. We have also an IMU, and then we have also the GPS, which is necessary for the tracking of the rocket. We developed our own custom PCBs, and we have 3 independent flight computers. We have the main flight computer, which is basically the whole brain of the rocket. And then we also have the quads flight computer, which is obligatory for the competition, so that they can track the altitude that you go to, and they can cross-check with the main flight computer data. And this year we even also implemented a redundancy printed circuit board, which is only responsible for the recovery part. So if all systems fail, at least we recover the rockets. So this redundancy is very important, even though on the mine flight computer, we also have some redundancies inside that system. So this year we are very confident that it will perform as intended. We do have an STM. We tested on an STM board, and then we implemented in one of those PCBs that I mentioned. And then we test these PCBs a lot. We test them in different conditions. We test the system separately, and then we test them all together to see how they go. We iterate. We have different versions of the PCBs so it's a very dynamic process and iterative process to build the rocket's brain, as to say. And this year we do have a camera, and we have a video recording system that will transmit video live, even though it's a smaller bit rate than it uses to store it. We will be able to have image from the rocket even when the rocket is flying, which is very cool.
How do you transfer data from the rocket to a ground station?
We have multiple patch antennas that are responsible to communicate with the ground station. We use the frequency of 868 because that was the frequency that the components that we were able to find on the markets heads. We believe that the 433 frequency is better because it's better range with less power. But due to the COVID problems, there are still some components on the market that haven't fully stocked up. So we weren't able to find the components that we needed to go on that frequency. One of our antennas, besides the patch antennas, is an SRAD antenna. So we developed, with the help of some professors in Technical, an antenna built by ourselves, and we will use it on the egg timer if everything goes well. And obviously we have the GPS antennas, which are responsible for the tracking of the rocket and giving us the coordinates of and the location of it. We will both transmit this data, but we also want to store it inside the rocket. And this will implement the black box, which is a small box 3D printed with some reinforcements that if the rocket isn't recovered, if the rocket is very damaged on impact, we can at least still access the data of the flight. And that is very important for us to know, to do a better diagnosis of what happens and what went wrong or what went right. And yeah, the ground station is also fully developed by us. And as for the auto tracking with video, that would be very cool. We don't have it. But I think that would be a very interesting idea to develop in the future.
How did you make your launch rail?
We built this year a new launch rail, which was very inspired on the launch rail that is used in the competitions. That's because we want to simulate as much, as many of the conditions as close that we have on the competition as possible. We built that to do some test launches, but this year we are planning on using EuRoCs because that's a launch rail that we've already used and we know that it works. So, and also to transport our launch pad is it's a very expensive thing to do. So we will use theirs this year. But ours, as theirs is built with aluminium and steel, it is not mounted on a trailer. But it can be configured to have increments of 3 meters up until 12 meters. So you can have a 3 meter, 6 meter, 9 meter, 12 meter launch rail, which is very interesting for us in the future, because if we want to build bigger rockets in the future, we can, and we can launch it from the same launch rail that we launch our rockets currently. We haven't got the necessity so far to have a filling system, but perhaps, as we said, when we develop the hybrid rockets, it will be needed and it will be needed to be implemented. And yeah, when the rocket is fully mounted on the launch pad this year, the way we designed our rocket, you can go there, remove a fuselage panel, and replace any necessary electronic components. You can charge the batteries, even though the rocket is still fully assembled and on the launch base, and you can correct anything that you see that is wrong. So that's very cool because that accelerates a lot of the process. If there's a scrub on the launch, you go there and you obviously first deactivate the ignition system, and you can do the things that you have to do without having to remove the rockets and then disassembling it all, and then assembling it and putting it on the launch rail once again. So yeah, that's a big improvement from last year.
How do you recover your rocket?
We actually design our own recovery system. We have a dual deployment system, which is required by the competition. This means that we have two parachutes. We have our main parachute, which is orange and black, and then we have our drogue parachute, which is blue and yellow. We use these colors so that it's easier for us to locate them both during the descent phase, but also when after landing, we can more easily locate where the rocket is. Besides that, we use CO2 cartridges that during the ejection moment, they are able to eject the nose cone so that we can then have the dual deployment system. We use Eagles this year, even though last year we used Raptors. Actually, this year we were also in our early design phase. We were also keen on using Raptors, but due to delays on the manufacturer and due to stock problems, they hadn't Raptors, and so we had to change a bit our design so that we could integrate Eagles. This year, we also implemented a new change in our recovery system. We have now shear pins, which are responsible for keeping the nose cone attached to the rocket. And then when the ejection happens, they allow for the nose cone to come out more easily than other process of attaching the nose cone to the rest of the rockets. As I said before, this system is all assembled and designed by us, but we still have some parts and some mechanisms that we don't develop yet. For example, the Eagles, as I said before, and also our line cutting system. So we use tender descenders that we have also already tested to make sure that they are working as expected. And so both tender descenders and Eagles are not developed by us. But the black powder that is used to activate them is in fact developed by us. Besides that, we also have some cords and some metallic connections that we buy. And about our parachutes, even though we make all the calculations and simulations for both of them ourselves, the drogue is sewn by us, but the main we haven't yet had the opportunity to develop it this year. But it's something that in the future we would like to do. Besides, as you probably know, we haven't yet had a chance to recover successfully one of our rockets. So that's actually one of our big goals this year, is to not just launch our rockets, but to recover it successfully. So that will be a great achievement for us. And so only after we are able to recover our rockets in this more conventional way, then we might think about developing some parafoil and some controlled new recovery system. But from now on, we are just only focusing on recovering it in this more, let's say, conventional way. For our recovery system, we have on these last weeks and months, we have been testing it a lot. For example, we have been doing some tug tests, which is basically consists on putting all the components of the recovery system inside the recovery bay to make sure that they all fit there perfectly. We have also done some ground tests that have gone successful. And besides these, we were also planning on doing a drop test from an helicopter from 3 kilometers high. However, due to the wildfires, the Air Force, which was helping us with these tests, had to go and, of course, help the communities that were under these wildfires. And so, unfortunately, we weren't able to do this drop test. But we are really hopeful that next year we will be able to test our recovery system this way, because it's a great way to, without launching, make sure that everything is working according to plan. Besides this, we have also tested our shear pins. We made some compression tests to to make sure that they can withstand the force that it takes them to rupture.
What do you want to use as a payload for your rocket?
So this year we have two different payloads. We have a 4U PocketSat, which, if you don't know, a PocketSat is basically half of a CubeSat, it's a cube with a 5 by 5 centimeter. So we have a 4U PocketSat, and then we have a 1U CanSat. The CanSat is made by a group of students, high school students that participated in the national CanSat competition, and they won the best scientific experiments. This was a cooperation that we made with Ciência Viva, which is also a company that organizes both the CanSat competition, and they are also involved with Portugal Space in many other activities, including EuRoC. So these payloads will perform a study on the mitosis of cyanobacteria and study the impact of rocket vibrations, accelerations during the flights on that process of mitosis. This is in part on the theme of life outside of Earth, so the impact of rocket transportation in life, especially bacteria, of course. And the PocketSat, our PocketSat is developed by a group of university students and researchers with different backgrounds from biology and engineering. We got into contact with them through an open call that we published to fly a PocketSat with us. They are going to perform an experiment on menstrual cups, which kind of the first one of its kind. This is a very big issue on space. I don't know if you are aware, but women, when they go to space, they have to be hormonally suppress their menstruation. So this is a very big experiment to bring awareness to this issue and to the issue that women have in traveling to space, and the suppression of the menstruation cycle in space exploration. We believe that is also very important for the future of humans in space and interplanetary travel.
Do you play Kerbal Space Program?
We are really big fans of this game. We have various members on our team that's played this game and that's even played it before coming to university. Kerbal Space Program is actually one of our sponsors. We have organized a giveaway where we offered some plushes and also some keys for people to play the game. And we really feel that this game is a really good game to interact with some formulas and some orbital maneuvers that then can be used in real life problems and in the industry. And so it's a great way for people to have and for younger people to have their first interaction with the space industry in a fun way, but also learning things that can be used in the real industry. This year, and a funny story, our control team is using the engine of Kerbal Space Program to simulate the Baltasar flight. And so that's something that is really cool.
How far have you gone in Kerbal? Like, have you gone to the moon, Venus?
I speak for myself that I played very little of the game, but I've gotten to the moon. I haven't played in a long time also, but we have the very big tryhards in our team. They aren't here today with us, but they would be able to talk a little bit more with you on this topic.
When they see this, they are probably going to be a little bit mad because we are not the greatest players, and so they would love to be here and talk to you for hours and hours about this game because they're really obsessed with it.
Do you have any big announcements or dreams?
Right now, we are organizing crowdfunding, which is a way that individual entities can also help our team and not just big corporations or companies. And so you can find it all about in our social media. And we have lots of advantages and prizes for people who help us with our crowdfunding. We are about half of our expected. About announcements in the short term. So in October, we would really like to have our first 100% successful launch and recovery. So it will be really cool for us to have a recovered rocket. We have been working throughout this year for that to happen, and we are really confident that it will become a reality this October. Of course, one of our big dreams is to win our category, and so we have been working hard for that to be a possibility. Medium term, as we said before, we are now in the early stages of development of our hybrid motor. So it will be really good to, in a 2-year span, for example, have a rocket with a hybrid motor. And in long term, of course, participate in the Spaceport America Cup. It will be a great opportunity for us to be with other teams from all around the world and to have an even greater experience near other teams that are not from Europe. So that's also one of our big goals. And of course, also in a long term, we are developing our TVC, and so it will be really great to have a kind of SpaceX rocket where we could land it with our TVC control, and so we are really working hard on that. So that in years to come we have rockets that can land themselves on Earth. Also, some of our dreams and some of our goals for the next few years is also to continue to enlarge our network and to talk to more companies and to the aerospace industry, and also to be even more in contact with other teams nationwide and European-wide, so that we can share even more knowledge and help each other grow in the future.
What are your personal plans for the future?
So speaking for myself, obviously we all have, in RAD, most of us have a dream to work in the space sector, and especially the rocketry sector. I personally in high school became into contact, since a young age I became into contact with rocketry, watching the SpaceX launches and SpaceX landing their rockets, which was a very big inspiration for me. And yeah, at RAD, that's what we love to do and what we want to do as a career. To have the dream job of being a part of a big company that builds space systems such as SpaceX, Blue Origin, whether it is NASA, ESA, or any other startups that are going to come up, that are still coming up in Europe on the private space sector, would be very cool. And to be able to do as for a living what we do on RAD would be...
Yeah, and I completely agree with you. We all at RAD, most of us would really like to work in this industry, and really we are all fascinated about what is possible to do. And I think that with the privatization of this industry, it is even now more possible for new people to work in this area, and for us to be part of this future. And so there are now more and more companies that are aware of the importance of this area, and I think that now we are in the phase where multiplanetary trips are breaking, and now we are in a very enticing and interesting time for us to be part of this industry.
Mm-hmm. Yeah, we sometimes even joke about making RAD a full-on company and making the first rocket company in Portugal,
so that we can work there forever.
Yeah. So that's something that we would love to do.
And we usually joke about, we are not just a group of students that makes rockets. We are a group of friends that perhaps makes rockets, and that's also very important to us, that we work with people that we really admire, and when we work with each other, and the atmosphere in the laboratory and in our workspaces is always very light, and we really like to work with each other, and that really helps us to develop these really complex systems. And yeah.
What are your favorite space movies?
I think the first one would be Interstellar, of course. That's probably the everyone's favorite. But then we have also Star Wars, The Martian with Matt Damon. It's also a very good movie about space. Then we have a classic one, which is 2001: Space Odyssey from Stanley Kubrick. And then we also thought about WALL-E because of the concerns about the environment and space debris. There's that one really known shot of when WALL-E comes out of Earth, and there's all these satellites. And so nowadays that there's fortunately there's a really more awareness about this problem. About YouTubers, we have talked about BPS.space, which we watch its videos, and our TVC prototype is really inspired by it.
We also, I wanted to have Everyday Astronaut, which is a very big YouTuber that I personally really like to follow up the missions and the launches of both SpaceX and Artemis 1 and everything that he accompanies and the people that he interviews.
Do you have any questions for me?
Yes, we would like to know if you are coming to EuRoC. We will be really excited to meet you here in Portugal.
Yes, I'm going to come, except if they will I don't know, cancel the flight the day before. But I think I'm coming.
Yes,
it's a high probability.
Are you excited for the Artemis 1 launch in October, if it happens, hopefully?
Yeah, I was excited. And now every time I'm less excited because will it launch? But yes, if it launches, it'll be exciting. Yeah. I hope it will work because I think it's a pretty expensive rocket.
Yeah, that's space industry for you, right? So things sometimes have to be very delayed, unfortunately. But hopefully it will work on October.
And also, it will be for a period of time the biggest rocket ever made.
Yeah.
Until Starship comes out.
Yeah.
Exactly.
If it comes out, there's always a probability that will explode.
Yeah. Yes. There's always a probability that will
explode.
Yeah. But on that topic, how is it to be a part of a SpaceX, Elon Musk founded school? What do you learn about? What do you do?
So I was basically admitted to the school that was founded by Elon Musk, which was Ad Astra. But then COVID came, and so they couldn't do it anymore specific place. Had to do it online. And also Elon Musk, I think, moved to Texas. Basically, this school became Astronova. It's basically the same school, the same professors, same students, only that it is online and there's no, it doesn't have any relationship with SpaceX, except the professors knowing SpaceX employees. You could choose what to study. I chose mostly science stuff, since I don't like that much studying English. I find it a bit boring.
Did you were you able to be a part of a normal school before you were admitted into that? Do you have that comparison?
So I did homeschooling before, and last year I did just the normal Italian school where every kid except me went and goes. It was boring. I also recently left Astronova since I kind of already knew all this stuff that was taught, so I left. And so now I'll do homeschooling again, just hoping that there's still more that I can learn. Okay. I'm sure that there's still more that I can learn. There's so much stuff in the world.
Yeah, of course. Yes. That's very cool.
And have you actually thought about in the future being part of a student rocket team or even creating one yourself? Have you
already created one. We have
really?
40 students. It's called Kerbal Space. We have students, we have projects. We basically don't have a rocket. We have 2 rockets, but they never flew. We only tested one of the 2, which was basically a pipe, a tube with a nose cone and some fins, and a rocket, a motor put in the center. I also make the rockets for this team, since motors are expensive. Mostly if you want to use 100 motors, then that can start to add up. I calculated that since we use these tubes here to make rockets, and these are free. These are when you get tin foil, they give you a tube and you can slice it into 3 pieces, and you got this. They work well. Paper, since it's more it's less slippery than metal or plastic, meaning that the nozzle doesn't slide out. But it's less. It still slides out.
Yeah.
So we have to fix that in some way. But yeah, so I calculated that the cost of one single motor would be about 50 cents. I calculated this a couple of years ago, and since there has been quite a bit of inflation, it probably be a bit more. But this is that is like two. Okay, so as fuel, this is like 3 to 4 times on ST's B44 if you do that size, and that you find like $3 a piece.
Damn, that's very cheap.
Yes, it's a very good price.
So and bigger motors cost more. If you buy a big motor like the one that you would use for EuRoC, I think that you can go in the hundreds of euros.
Yeah. Yes, I believe so. Hundreds of euros minimum, I believe.
Although we will still use it, the EuRoC one for the EuRoC rocket. And we're using these just for tests.
So you're planning on participating in EuRoC next year?
Yes, we would like to do next year, but I don't think we'll be able to do it next year. Okay. Except if we do like the bare minimum, to call it, on a rocket that can go at EuRoC.
Would you like to have a career in rocketry in the future?
Yes. I think I would probably either work for a company like SpaceX or Ariane, or I would start my own company. Although with SpaceX and Ariane, another company would have a lot of competition.
It's a very tough business to get into. Yeah, what part of rocket development do you like the best? Do you find more fun?
I like propulsion.
Okay.
Because I find it interesting. It is. I'm not that good with electronics. Recently, I'm not that bad. Recently, I've done a bit of electronics. But I definitely find myself better in like mechanics or chemistry. And that's sort of like how motor. I also like structure since it's basically building the rocket.
I agree with you on that.
Also find coding a bit boring because like I code something but then I don't see the result.
Yeah. I sympathize with you a lot. I share your opinion.
Well, you can see the effects of the result, but you can't find the like a piece of code lying in your rocket.
It's more satisfying to actually build it and like the outside structure and the rocket itself, you see it and you can hold it and it's something tangible that I designed this and this is now in my hands and it's going to fly. It's more, I share that opinion too. I don't think we have any more questions, but if you can ask us away anything you'd like.
Yeah.
Thanks for joining me in this interview.
Thank you for interviewing us.
Thank you.
And see you on EuRoC, hopefully.
See you in Portugal soon.
Yeah.